We are recording. All right, so everything that we do has a structure, right? When we're declaring a variable, we've discussed we have to have a type, we have to have a name, and we have to have a value. This is how we declare a variable. King has a question because I'm not sharing my screen. Is this better? Get rid of that. Oh, no. I want to get rid of that. Perfect. All right. When we are setting a variable, we just need the name and the value. And when we are calling a variable, it's going to be probably either on the right side of the equal sign or in a cout, but you just need the name. These are the three things we can do with variables. We can declare them, we can set them, and we can call them. Declaring the variable declares it. It sets it up. It allows you to have the variable for the rest of the program. Setting the variable changes the value, and calling the variable accesses that value for something else. But this is the structure. The structure matters. If you do it differently, it doesn't work. Syntax. An if statement has a structure. The structure matters. If you don't write the structure correctly, your if statement's not going to work. Structure's pretty straightforward. You need an if. You started off with if. That's why we call it an if statement. You need some conditional, and then you need some event. The structure of an if statement. Now, when we run a function needs a type, a function needs a name, a function needs parameters, and then the function needs the event. The structure of the event generally will always fall in between two brackets. Same thing is true for an if statement. The event happens between two brackets. So it's similar to a function in that way. What I'm going to do to demonstrate is I'm going to create two variables. I'm going to create an integer x, set it equal to 7. I'm going to create an integer y and set it equal to 9. And then I'm going to start my if statement. So open it up with an if and an open parentheses. When I use the word conditional, what I mean is some sort of Boolean comparison. I guess I'll put that up here. A conditional is a Boolean comparison. So a Boolean can be what? It can only be two things. What are they? True and false, which means that this conditional here can only be two things. It can only be true or false. In the event that the conditional is true, the event happens. It runs. It exists. When the conditional is false, it is as if the event does not exist at all. It never happens. It fails to run. It gets skipped. Whatever terminology you need to say, when the conditional is false, the event does not exist. So, some conditionals. X could equal Y. This is more structure, more syntax. Anytime you are comparing two values using Boolean operators, the comparison has to have a double equals. Because a single equals sets a value. We've already established that using our variable declaration and our setting a variable. A single equals sets a value. A double equals compares values. So we're going to put our brackets. And the event we're going to do is to print out, this is true. I may have done that backwards because I regularly do that backwards. So when X is 7 and Y is 9, our output is what? This is false. When this is false, what happens to our event? Nothing. So this never happens, which means our output, because at no other point in our code do we have an output, our output is nothing, because nothing happens. So one Boolean operator, equal comparison, doesn't happen. Other Boolean operators, greater than. If we were to run this, what would happen? Nothing. Compares X is greater than Y. We know that 7 is not greater than 9, so nothing happens. Another Boolean operator, less than. In this case, we run it, what happens? It says this is true. That's our output. Our event actually takes place. What operator is this? Not equals. We discussed this when we went over Booleans. Exclamation in most programming languages is just shorthand for not. Not equals. So we're going to say if X does not equal Y, it should say this is true. Because X is 7 and Y is 9, they are not equal. What's that? You can, and we will. Yeah. Mike wants to know if you can put ors in your conditional, and the answer is yes. You can also put less than or equal to, and you can put greater than or equal to. So the conditionals you can use are equals equals, greater than, less than, not equals, less than or equal to, and greater than or equal to. Hey, George. All right. The simple structure of an if statement. Now, we talked about camel case and snake case as far as both ways are appropriate for defining, declaring, naming a variable or a function, right? There's a couple of syntax options when you're dealing with if statements, all of which are acceptable. In this case, both of which. When I write an if statement, I always put my first bracket at the end of the conditional. This is the way that I was taught to do it. We had to write everything by hand, and this is just the way that we wrote it. Common practice today, best practice, is to return this. Now, you can return it directly under the if, or you can return it and tab it over. Both are acceptable, but you'll notice if they are lined up, you get this green dotted line between them in your compiler. If they're not lined up, that green dotted line is still there, right? But it's harder to read exactly what's going on. So the best practice is to always line up your brackets. And that's true also for your functions. So your main function is now lined up with your bracket. I don't do that. I guess I'm lazy. But I just don't do that.
Wait, line up your bracket, or it's not really lined up with the other bracket. It's lined up with the left margin.
Yeah, so we have int main, right? And now we have this bracket here is lined up with this bracket, right? And then we tab over all the content inside of that. Oops. And eventually we get to another bracket and if statement, and that bracket is lined up with this bracket.
Oh, line up your brackets with one another.
Yes, yes.
Okay, I thought you were talking about lining up your parentheses with your
No.
other bracket.
So aligning your bracket with the corresponding bracket associated with it, right? So in code, at some point, you're going to have probably a ton of different brackets for a lot of different things. If statements, loops, try statements, switch statements. There's a lot of things you can do that's going to have brackets. When you're structuring it, when you're writing it, you want to make sure that every bracket that opens, one, that it has a corresponding closing bracket. If it doesn't have a corresponding closing bracket, your code's not going to run. But to make it easier for readability, best practice is to have the corresponding closing bracket in line with the corresponding opening bracket. So you could write it like this, right? And because the way C+ works, this code is still going to run and it's going to be successful. But it's a lot easier to read if it looks like this. That's just a best practice. You won't see me doing it that way most of the time, just because I like my brackets to be in the wrong place, I guess. I will make an effort to do it by best practice. I won't always succeed. But if you can line them up, it's better. Which also brings the next point of structure. When you have a bracket, you can have your event be in line with the brackets. It will run, but best practice says that your event should be tabbed over. It's just like the start of a paragraph. When you're writing a paper, you don't have to put a tab at the start of a paragraph, but we all do. Why do we do that? Because it's easier to read. Code is the same way. A lot of stuff that you do is just so that it's easier to read. Now, Python specifically forces you to do it this way. Python took the guesswork out of it. The tab is actually what determines the event. But C++ is not that.
Is that best practice for line text?
Readability. I generally will put a space after and before brackets. I think that's because I'm just getting older. It's harder to read. But for most people, this works too. I've always put a space in there. I think it's just because it's easier for me to read. But it's the same as like double spacing a paper, right? Like some of your instructors are going to ask you to double space a paper. And if you're writing an APA format, you have to double space the paper. But it doesn't change the meaning of the paper if it's not double spaced. So it's just easier to read. So from my perspective, if you can read it, then however you space it is fine. The only thing I really care about is the tabs. All right. So simple if statement. You need if, you need a conditional, and then you need the event. Pretty easy, straightforward. Now, Mike asked if we can use or, right? So let's say if x is greater than y, we wanted to say or x is less than y. Now, in this specific compiler, it's reading or as a legal code. Older C++ compilers won't read or, and they won't read and. It doesn't mean anything to them. So for the sake of this class, because we're going to be in this compiler all the time, you could use or and, but don't. The or symbol is the two bars, which is above your enter key, and you have to hold down shift. The button above the enter key that looks like a bar, I don't know, above the slash, this represents or. And then a double ampersand represents and. Oops. You want to do not and? Not and is not a thing, because that would just be or, right? So when we're dealing with these conjoined conditionals, right, more than one, you can write something that looks like this. You can have an or statement and an and statement. This would get really confusing because x could be greater than y, but that means that x is not equal to y. So it will never be true, right? But if you read it, if x is greater than y or x is less than y and x is equal to y, that'll still never be true, right? It is hard. It's hard to rationalize when you start using ors with ands together inside of the same conditional. There's a whole logic tree chart for drawing it out, writing it down, what happens in this case, in this case, in this case, in this case. I'm going to ask you not to do that. For everything we need in this class, you can do it with multiple or statements, or you can do it with multiple and statements. But don't mix and match or and because that's just, it's hard to rationalize what it's going to do. And it's not consistent between languages. Different languages will order them. They have a different order of operations. So it's not consistent to figure out how it will run through the system. So we don't. But we'll talk about ors and ands. In this conditional, the entire condition has to report true or false, right? Everything inside of these two parentheses is the condition. So if x is greater than y or x is less than y, that's going to report true in every instance where x does not equal y. Only when x equals y will it report false. If we tried to put an and here, it's never going to be true, right? Because x cannot be both greater than y and less than y. Just simple logic applied to it. So when we're writing our code, we talked last class about this desk check. Sometimes it's an idea of just a basic logic check. You will be writing code at some point, and you will write something stupid like this. I promise it will happen. It does happen, right? And then you will run your code, or you will run your game, or you will run whatever it is you're running, and it won't work. And you'll be angry because you feel like you've done everything correctly.
Philo slide it right through.
What's that?
Philo will slide it.
Yeah, because it's not wrong. There's no syntax wrong with it, right? So it'll get through. It'll produce no errors. But you really meant to do the or. You just did the and. Some of this is proofreading, right? We have Grammarly. We have spell check, which does a lot of proofreading for us. We have been, what's the right word?
Dumbed down.
Dumbed down. Our ability to proofread is low because we don't have to in most of the writing that we do, right? Something is always proofreading for us. We have the syntax that will proofread for us, but it doesn't proofread the logic. So when you write your code, just have to be really deliberate with the things. And we'll eventually get to a lesson on troubleshooting, which is where we solve these problems. But the best way to solve them is to not make them. And that just means be very deliberate in what you do. Talk through what you're writing to yourself to make sure it makes sense. This sounds stupid. It really does. But if you read the line as you wrote it, generally you'll know if it makes sense or not. Because if I said if x is greater than y and x is less than y, I would immediately know, well, that was stupid, right? So you can compare it with this. Now, in these conditionals, you can have as many conditions as you like. So if x is equal to 1, or x is equal to 2, or x is equal to 3, or x is equal to 4, or x is greater than 10. I have all of these conditionals in here, right? But the whole thing has to be, it only returns one true or false. Make sense? So if x were 5, what would this return? False. Because x is not 1, and x is not 2, and x is not 3, x is not 4, and x is not greater than 10. So none of these individual things are true. So this gets to the idea of the table that I was talking about before. So obviously this is pretty straightforward because these are real numbers that we can see and interact with. But we would make a table where x equals 1. We have true, false, 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 right? In an OR system, only one of these things has to be true. So we make the table, we see that one of them is true. That means that the whole thing has to be true. And we do the same thing with 2. And we'd go through the table. It seems stupid when you're dealing with real numbers, right? But if you're dealing with calculus, and each one of these is some sort of calculus variable, right? You have to solve it to figure out if it's right or not. This is the desk check. You know what happens when x is 1 and when x is 2. So that when x is 450, you don't have to do the math. You can just trust that everything is correct. But you have to go through, when you have a ton of conditionals like this, it's good to go through and make the table. And the table is different if they were ands. which obviously this is never going to be true because X is never going to be 3 and 4 at the same time. But if you had an AND table, going to look like this, right? Looks exactly the same as the OR did, except when you're using AND, all of these have to be true. If it looked like this on your table, not in the code, but if this was your AND table, it would still be false. Because when you're using an AND table, every single one of them has to be true. So that's the basic structure of an if statement. But we can do a little bit more than that. Because if all you can do is just if this, then that, you can only go so far, right? But we can have nested if statements. And a nested if statement is the same idea. It's one if statement housed in another if statement. So you could say if X is greater than 3, X is greater than 15. We'll do that. So let's say X is greater than 3. You wanted to set Y equal to 45, right? Anytime X is greater than 3, you want to set Y to 45. But if X is greater than 15, you want to set Y back down to 15. Why would you want to do this? I don't know, right? But I'm going to move this out of the way because it's in my way. So in this instance, X, let's say X is 7, which it is, right? When it runs through the code, it's going to set Y to 45. And then it's going to check again. Because X was greater than 3, it's going to check this nested statement. If X is greater than 15, it's going to set Y is equal to 15. This isn't going to happen because X is not greater than 15. But let's say X were 2. This is going to return false. When this returned false, that means this entire event never happens. This event never happens. So it doesn't matter. This one never runs because this whole event never happened. Does that make sense? The concept of a nested if statement is that the thing on the inside only matters if this first statement is true. So let's say X were 17. Well, is X greater than 3? Yes. So then it's going to jump. It's going to run all the way up to this one. Is X greater than 15? Yes. So then it's going to run this chunk of code. If X is 7, it's going to get to here, but then it's going to ignore this entire chunk of code. Now, you could have as many nested ifs as you wanted, where it does different things. And we're going to do some of that, right? But the idea is that the nest only happens if the top line is true. And if you add another nest in here, right, then this one would only ever check if this one were true. Now, sometimes, like let's say I didn't have this Y is 45 here. Sometimes these nested ifs could be handled with an AND. Right? Because this would do effectively the exact same as the nest. The difference is that you couldn't break these up and do something different when X was 7 than you did when X was 17 or 700, right? So, I mean, this one, I guess all you really need is the X is greater than 100, right? Because it's an and, all of them have to be true. But sometimes using these kind of bundled conditionals, right, is better, but sometimes you need to do it in a nested system just because it depends on what you're trying to do with the code. So you can, both structures are correct depending on what you're trying to do. So that's a nested if. The next statement that builds with the if is an else statement. So if X is greater than 3, say this is true, else this is not true. So anytime that this returns true, then this first event is what's going to happen. That's what's going to run, and then it's going to skip everything else. It's the else. In the event or the situation where this returns false, then it's going to jump to this statement, and that's the one it's going to run. So we call these a selection tree, right? You can select one or the other, but both can't be true. So the else only happens when this conditional returns false. It's the only time this else exists.
Okay, you have sequential.
Yes. So you can have an else if.
I'm talking about like before that, like before the else. Like if you were to go to the bracket right above the else. Yeah, and just keep saying if,
Yes.
if, and it just keeps.
Yeah. So let's say trying to figure out demonstration for that.
In that case, if it's false, it just bounces down to the next if.
Right. So if this one returns false, right, then it skips over that and it goes to another if statement. If this one returns false, it skips over that, right? Now, the else if is different. And the only reason it's different, when this is true, right, it skips this entirely. But if you don't have the else there, then it's going to check to see if X is greater than 3. And if it's true, then it's going to run the event. Then it's going to check to see if X is less than 3, right? So the benefit of the else is just efficiency in this case, right? When this is true, everything else gets ignored. But every if statement you have has to run unless there's an else in front of it. Now, you can have a stack of 45 else ifs long. And if you're trying to play the game 20 questions, you're trying to write it, you're going to end up with 400 else ifs that are stacked together and they look really terrible. It's a pain in the butt to write. However, the else only is compared to the last if. Does that make sense? So if you have an else if here, this else is only attached to this last if statement. Now you can only get to this if this one is also false, right? But once you get down, the else statement only applies to the if statement before it, directly before it. Does that make sense?
So if your first if is true,
Mhm.
it skips everything and goes
Right.
right past the.
If it's true, it will run this event and everything else is skipped. But if it's false, then it goes to this one. And if this one is true, then it's going to skip everything else. And if this is false, then it runs the last one. So, in some ways, you could do a lot of stuff using nested ifs or this structure, depending on the logic that makes sense to you. But the idea is an if statement can only be true or false. And this is where we get into flowcharts, right? Like, do I want to eat breakfast? Yes or no? Well, no. Okay, go to work, right? Yes. Do I want to cook breakfast at home? Yes or no? No. Okay, well, then go get food, right? Or whatever it is. But you can only ask yes, no questions. So with if statements, it really is like playing 20 questions. Have you played 20 questions? Do you know the concept of the game? Does anybody not know the concept of the game? Okay. So if statements are just playing 20 questions with the computer. That's it. Sometimes it's 100 questions, sometimes it's 2, but the idea is you are asking yes, no questions only, and those yes, no questions lead you to a result.
If you didn't put the else, then even like at the else if, I'm sorry. Then if you had multiple statements, even if it hit a true, it would execute the event and then continue to test, even though you've already had a true. Like if the next statement was if
Yeah.
X equals whatever.
So in this case, X is greater than 3, it's going to run this event. And then it's going to check to see if X is greater than 5. And if it is, it's going to run this event. But if it's not greater than 5, then it's going to run this else. But this else is only attached to this if statement. It is not attached to this if statement. The else is only attached to the if statement directly before it.
Okay.
Now, sometimes you'll have an else if, right? And now this, technically, this one only happens if this one is false, right? But it really only happens if this one is false. The else is only attached to the if statement directly before it. Or other statement that has an else. But in this case, it's an if statement. Does it make sense? Okay. So these are the 3 structures of if. You have an if, you have a conditional, you have an event. You can have an else if with a conditional and then an event. Or you can have an else, no conditional, but just an event, right? When you have an else, what it's really doing is connecting to the conditional in the if statement before it and checking if it's false. But if you get to the else, it was false. So we could write 20 questions now, right? If user word is a person, right? Then do this. If it's not, then go to this question, right? And there's a series of questions you can ask. Is it a person? No. Okay. Is it a place? No. Okay. Then something else, right? I'm not good at 20 questions, but you get the idea. Is it red? No. Okay. Is it blue? No. Right? You only ask yes or no questions. You could write that in code with the knowledge that you have now, but it would suck to do because you're going to have 40 different nested if statements, 40 different else ifs, 100 different else ifs, maybe. I don't know. It gets pretty gross. But what we're going to do instead, we're going to use the basic if statement with the variable and the user response to create a simple user guessing game. We're going to do that. We're going to take a 10-minute break, and we'll come back and we'll do that. It's fair?